Okay, class, welcome to polar coordinates. So we're going to do polar coordinates, which is an ordered pair r comma theta, and so far we've only done xy in the xy axis, the rectangular system. So now we're going to plot an r comma theta, where r is a directed line segment, so it's a certain length, like a vector, and then theta is going to be our angle calculated in a clockwise direction. Sorry, a counterclockwise direction. Okay, so we're going to plot some points. Okay, so the first point is 5, so it's going to be a ray or a line segment of length 5 and pi over 4. So we're going to do our angle pi over 4. So we're just going to count our angle, so starting on the 0, the positive x-axis, and we're going to find the angle pi over 4. So on the pi over 4 line, we're going to go a length of 5 out. So we're going to count 5 circles out. 1, 2, 3, 4, 5. Okay, so I'm going to label that point A. So for point B, we have negative 7 pi over 6. So we're going to count, since it's a negative angle, we're going to count negative 7 pi over 6. So we're in twelfths, so we need to go 14. So minus 7 is the same thing as minus 14 pi over 12. So we count 14 left. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here's our angle. We're going to go 4 out. So count from the center. 1, 2, 3, 4. And that would be B. For C, we have a negative 3 for length. So if it was 3, we would count 1, 2, 3 out on the pi over 3 line. But instead, if I highlight my pi over 3 line, to go a negative 3 means on the pi over 3, but instead of going out towards pi over 3, we're going to go 3 the opposite direction. So here's our point C. And then for D, you go minus pi over 12, so we know to go the negative direction. So we're going to go on the pi over 12 line, the minus pi over 12 line. But since it's a negative, we're going to go the opposite direction. Okay, so the negative angle tells you to go clockwise. So we went clockwise pi over 12. And then the negative length tells you instead of going out towards the negative pi over 12, we go out the opposite direction, 5. 1, 2, 3, 4, 5. And that would be D. And that is how you plot a polar point. So you are going to need to print out the polar graph paper for your homework. Okay, let's move on to the next slide. So just a quick review from trigonometry. You have some angle theta, and cosine is adjacent over hypotenuse, or x over r. Sine is opposite over hypotenuse, or y over r. Tangent is opposite over adjacent, or y over x. And then if you use the Pythagorean theorem, x squared plus y squared, you get r squared. So these are the formulas that we're going to be using in this section. Okay, so keep those in mind. So here we go. Example number 2. We're going to convert from rectangular coordinates to polar coordinates in degrees. So we're going to do it in degrees. I'm going to show you how to do it by hand, and then we're going to do it on the calculator. So for polar coordinates, we're going to need an r and a theta, because polar coordinates are r comma theta. So to find the r, we're going to use x squared plus y squared is r squared. And since these are rectangular coordinates, those are x comma y, because the polar coordinates are the r comma theta. So we have our x and we have our y. So if we do that, then we can do minus 2 squared plus minus 5 squared is our r squared. So r squared is 29, where r is square root of 29. Okay, so that's how we find our r. So now we need to find our theta. To find theta, we're going to do tangent of theta. Tangent of theta is y over x. So if I just quickly plot this point, negative 2, negative 5, it's going to go negative 2, negative 5. So it's this point here. So I have my opposite and my adjacent, and I have my reference angle, theta. So this theta here, what this is going to do is it's going to find just this little angle here, my reference angle, which is really called we've been calling theta prime. But at -2, -5, it's really going from the positive x-axis all the way over. So when I do this tangent of theta, it's going to find my theta prime, just that angle inside the triangle. Okay? So, tangent of theta, we don't know what theta is, that's what we want to find, but y is -5, my x is -2. And so I can just do on my calculator, theta is arctangent of 5/2, and since we want it in degrees, we know the mode on our calculator needs to be degrees, and you get 68 degrees. I'm going to round it to the nearest degree here. Okay, so you should follow along, make sure you're in degree mode, and you do arctangent of 5/2, you get 68 degrees. Now 68 degrees is just this little reference angle in here. Okay, that's my theta prime. What I really want to do is I want to find that big angle all the way around. So that's 180 degrees plus 68 degrees. So my theta is 180 plus 68 degrees. So my theta is 248 degrees. So my polar point is r comma theta. So it's root 29 comma 248 degrees. Okay, so in this example, because we're in quadrant 3, we had to add 180 because it's halfway around is 180 plus a little bit more. Okay, so here we have 2 comma -4, so we're down in 2 comma -4, or this point down here, so my theta prime is going to be that much, but the theta that we're going to actually want for r comma theta is that much. We're going to use reference angles again. Okay, so let's find r. X squared plus y squared is r squared. My x is 2, so 2 squared is 4, plus y is -4 squared is 16. Our r squared is 20, so r is the square root of 20, which is 2 root 5. Then we're going to do tangent of my reference angle, my theta prime. Tangent is y, my opposite is -4, and my adjacent is 2. I wrote -5. I said -4. -4/2. So my theta prime is tangent inverse of -2, because this number is -2. Okay, and when we plug that in on the calculator, so you should still be in degree mode, tan inverse of -2 is -63 degrees. Okay, because it was the -63 degrees. Okay, what that tells you is that the measure of the angle inside the triangle is positive 63 degrees, but we want kind of the big reflex angle, the one that's out there, which is the whole circle, 360 degrees, except for that 63 degrees. So our theta, this big angle out there, our theta is 360 degrees minus 63 degrees. So our angle theta is 297 degrees. So our r comma theta would be, our r is 2 root 5, and our angle is 297 degrees. Okay. And that is our angle and our r. So that is how we convert from rectangular to polar. So of course, since 297 degrees and -63 degrees are coterminal, another possible representation would be the 2 root 5 comma -63 degrees. So this would be an alternate point, which is also true. Okay, so let's move on to the next, the calculator portion. So I'm going to pull up the calculator here. Okay, so here I have the calculator. I want you to write down the notes of what we're going to do. So we're going to convert from rectangular to polar. We're going to do the same problem we just did, except we're going to do it on the calculator. We're going to do the first problem. So we're going to go to the mode, And we had our answers in degrees. We want to make sure we're in degree mode. And instead we did function, instead of parametrics, we want to do pole for polar. So I'm going to arrow down and highlight polar and press enter. So now I'm in polar mode. Oops, that stopped working. Okay, well, let me get that to work again. Okay, so we are in degree mode, and then we're clicking on PLL for polar mode. So once you have that, then we're going to go here, and we have our r comma theta, so we're going to go to the angle menu. So go to second angle, so here's the angle, and we have r to PR, so this is rectangular to polar, and it's going to spit out the r coordinate, rectangular to polar, and it's going to spit out the theta. Okay, so we're going to choose option 5, so either arrow down or press on 5. So what's our rectangular point? So if we do the first problem, it was -2, -5. So you get 5.3. We had square root of 29, so let's just check. If we do the square root of 29, you get the same answer. Okay, so we got the same answer. So this is the same r, and so you go second angle menu. Now let's get the theta, option 6, and we're in degrees, so it's going to spit out the degrees. So -2, -5, and we get -111 degrees. We got 248 degrees. And if you think about a circle, we went positive 248 degrees, they went -111.8. So those two are actually coterminal angles. They just gave us the negative. They're both correct. Okay, so jot down these notes. Remember, it's the second angle menu, and we did option 5 and 6 for this to convert from rectangular to polar. So jot that down in your slides here. Okay, so let's move on to the next, and we're going to convert the other way. So for this problem, we're going to convert from polar to rectangular. So we have polar, which means we have an r and a theta. So this is my r, and this is my theta. And what we're going to do is we're going to convert to get our rectangular, our x comma y. So if we were to just quickly jot this, you would go to angle 7 pi over 4, which is that much, and we would have gone 2 circles out. So that's essentially what we have. Okay, so when we convert this, we're going to do similar things. Okay, so we need an x and a y, and I know that cosine of theta is x over r, and sine of theta is y over r. And if I just solve for x, multiply both sides by r, x is r cosine theta, and this tells me that y equals r sine theta. So I have an r and a theta I'm going to plug in, and I'm going to get my x and my y out. So my x is r, 2 cosine of 7 pi over 4, and my y is 2 sine of 7 pi over 4. 7 pi over 4 is on the unit circle. I know cosine is a positive root 2 over 2, and sine is a negative root 2 over 2. So it's 2 times root 2 over 2. You can pull out your unit circle if you need it. Sine is negative root 2 over 2. The 2's cancel. So my x is root 2, my y is negative root 2. So my rectangular coordinates are x comma y. My x is root 2, my y is negative root 2. So let's go to the calculator, and let's check that we get the same answer. Okay, so we're going to go back to the angle menu, and this time we're going to go from polar to rectangular, so option 7, and if you scroll down you get option 8. So option 7 is polar to rectangular x, and 8 is polar to rectangular y. So let's choose option 7, and we had 2 comma 7 pi divided by 4, and you get 1.9. We got root 2. So the issue was it's different because square root 2 is 1.4. We are plugging in a radian measure, and our mode was degrees. So you have to convert to radians here. Quit and do the same thing again. Second answer, oops, second entry.